All right, welcome back again, and hopefully you watched the video and understand the previous video about our basic addressing system that we use in Stargates and wormholes. All right, and just to kind of recap, we're going to be understanding more about polygons and circles and as they're related to the Stargate addressing system and wormhole addressing systems. Okay, so before we were talking about how polygons, the more number of sides you have, the more number of possibilities that you have of y1 and y2 not being in the center of this polygon or of this circle. And we're going to go into more about circles right now. Okay, so I'm going to erase this nastiness, because math is all nasty. We don't like nasty. Well, some of us don't like nasty, but some of us do, I guess. That's why I'm teaching you. Okay, anyways, so let's go ahead and start about talking about circles. I'm going to try to draw a nice circle without a compass. It's, well, it's better than my previous circle. And that's really an illustration of something that I want to talk to you about. I don't know if you probably read much about Euclidean geometry and the people that came up with geometry in ancient Greece. But actually, the circle was representative of something that maybe we can't attain. Perfection, logos, that kind of thing. In nature, we don't really find a perfect circle anywhere, at least not that I'm aware of. We find ellipses, we find eggs. An egg isn't round. It isn't like a ball, like a basketball or anything like that. It's really just a concept of something that symbolizes perfection. Okay, and there's a lot of very interesting, very ironic things, and if we study the relationship between geometry and nature, we're going to be going into some of that with a lot of my videos. Okay, but primarily right now we're going to be talking about polygons. Okay, so this is our circle, and it's not perfect, so we're going to keep trying to make it a little better. Okay, but really polygons are going to be something that is not circular at all. Okay. We're going to be talking about a square, because a square is a polygon, really. Poly meaning many, gon meaning sides. So let's look at our little square here. Our little square has 4 right angles, 4 sides. We call it a square. Okay, this might be on a little tangent or something, but one very interesting thing about a square is that you can create a square by intersecting 2 triangles, isosceles triangles. And that's one very interesting thing. That's just kind of a tangent though. We're going to not worry about that too much now, for right now. Okay, so anyways, we have this square of ours. Sorry, that's That's not a square. Moving on to a little better. Okay, so we have our square. And we know that the angle of each corner is going to be 90 degrees. Everybody's going to know that unless you've been, whatever. Everybody knows this. Everybody knows this. Okay, now if we want to make a polygon out of this, how are we going to do it? Okay, it's very, very simple. Now, if we want, let's say, if we want to make this a polygon, we can take the angle of each side, and we can bisect it. We can cut it in half. Each one. Okay, and then we automatically, and let's erase this. Crap on that side, crap on that side, here, and here. The extra long lines get rid of also. Okay, now that was interesting. We just cut the sides in every one of the sides in half. We just got an octagon. Okay, and so now if we want to know what the angle is, we can just take and divide 90 degrees from the square in half. Okay. Now we can actually do this an infinite number of times. Keep dividing. Cutting the. Let's do it one more time. We can cut it here, 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 and here. Okay, that's a lot of cutting. Obviously, this is not going to be a very good-looking polygon. But what we just did is we went from 4 sides to 8 sides, and now if I erase the other things, it will be 16 sides. We can do this to infinity. And the more times we cut it in half, the angle in half, the more we are going to be approaching a circle. But it will always have angles, no matter what. Even those angles, maybe they could be nanometers across, that the angle could be. To our human eyes, the ability to our human senses to sense those angles will reach a limit, and we will say, "Oh, that's a perfect circle." But it's really not. We just keep looking further and further into the fractal universe, and this is what we get. Okay, but this is all great and everything. How we just learned what infinity really means, or one take on it at least. However, how do we get this to be useful in our quest for understanding Stargate physics, and in particular the Stargate addressing system? Well, really, what we can use a particular mathematical formula to explain this constant division, and we can just create a nice little function, a nice little formula of our own for this. And it's really, you can really use like a geometric or arithmetic formula for this. And lucky for you, I've already done all the hard work. And so what we're going to do, I'm going to erase this so we can write a formula out so you can see it. We're going to call this function, or this particular angle that we are calculating, P. Okay? And P is going to be, actually we're going to turn this into a function. The function variable, dependent variable is going to be n. So this is going to be 90 degrees, and then 2 raised to the n minus 1. And all of this is going to be divided by 360, as you can see. Get out of your way there. And the higher number of n means the higher numbers of sides of the polygon. All right. So the higher number of sides, the more accurate you can be, and also the more non 0, solutions to the equation that you will find. Okay, so that's p function of n 90 degrees, all multiplied by 2 times n minus 1 all over 360. So there you go. There's your polygon equation, and see you next time.